Hello, my name is David Nunez, and I'll be presenting my action research project on project-based learning in a sixth grade science classroom. As educators, we're constantly exposed to data from our students, whether it's through interactions, observations, or assessments. How we utilize such data can help determine how successful we are in helping our students. Action research helps us utilize data in a meaningful way by allowing us to reflect. It allows us to find areas of need within our classroom. It allows us to conduct research and use research-backed techniques to implement into the classroom. And thanks to an cyclic process, it allows us to continue on based on new findings or new needs that we discover. Action research can begin with an observation. An observation that I made in the beginning of the school year was that through Amplify, it had the same pattern through the first few couple of months. It had students mostly writing. It had students taking assessments that were just multiple choice questions and essays with little to no hands-on activities. And I had students come up and make comments such as, Mr. Nunez, can we have two math periods instead of one? Signifying that they were not liking science, or students saying, oh no, science. And a few times when I would walk around, they would let me know that they weren't liking the activity, or they would have side conversations, or start playing games. I wanted to make sure, though, that there was not only a problem with the loud majority, sorry. So I gave students a survey. In the survey, I used the Likert scale. 1 represented strongly disagree, 2 disagree, 3 neither agree or disagree, 4 agree, and 5 strongly agree. For the question or statement, I think science is fun, Class A responded with 74.3% of students within a 2 or a 1, signifying that most students disagreed and thought that science was not fun. For Class B, it had 60% of the data rely within a 3 or a 2, meaning that they didn't care either way. So they had no opinion towards being fun. So I knew that I had to break the cycle and do something. So I started on a journey of research. After reading and thinking about what is going on with Amplify, and I saw that it was lacking the hands-on component, I ran into project-based learning. Thanks to readings from researchers such as Caraba and Farmer, I was able to learn that project-based learning not only enhanced engagement, but it also had motivation increase within science. And thanks to readings from researchers Juti and Hugerat, I was able to learn that not only was project-based learning useful overall, but it helped fill in gaps in science by creating curriculum that's a little bit more engaging and meaningful for students. As I read more articles from many more researchers, the words that popped up and stood out were engineering design process. The engineering design process is a set of steps that helps guide students through project-based learning or hands-on learning. It helps it more digestible and helps students understand the curriculum a little bit better. So that led to my research question. My research question is, how does project-based learning impact student engagement in a sixth grade science classroom? So I had to begin a plan. The plan was going to have students do a project-based learning activity for 7 days connecting to our plate motions unit, which had students create a bridge. First, I introduced students to what project-based learning is. Then I showed them a video that taught them the steps of the engineering design process in a way that was easier for them to understand, which was a YouTube video that connected the engineering design process to a taco party. The next step is students were presented with their challenge. So they got to know what their challenge was and their requirements. After that, they began conducting research on what they had to do. For brainstorming, they came up with different ideas, and then as a group selected which idea they liked the best. After that, the step that took the longest, building a prototype, which is also a step that students enjoyed the most. Then the students got to test. After that, they did the step that to me is the most important. They got to iterate. They got to see that making mistakes, it doesn't mean it's over. It's just the beginning. They got to see that they get to try again, and they actually learn from those mistakes. And at the end, they presented the process and their findings to the class. Data collection methods. The way that I collected data was using an observational engagement checklist. I had students write in their journals at the end, and I gave them a survey so that way I could have student perspective. For the engagement checklist, every 10 minutes I checked students' engagement, and there was 3 categories: actively engaged, passively engaged, and disengaged. Actively engaged meant that they were continuously looking at me. When I was giving a lecture, or students were actually collaborating together and having conversations related to the project. Passively engaged meant that students were sitting quietly but doing their work. Disengaged meant they were doing anything else besides their actual project. For the journals, students would reflect on what they thought went well for them and for their group, what they think they could improve, and what changes they could make the next day so that way things would go more smoothly. And for the survey, it had different statements that related to what they were doing in class, so I could see if they enjoyed the project or not. So for the results, there's the engagement observational checklist that I created. For the results, Class A, this bar graph shows student engagement throughout the 7 days, so the average. And on average, 60% or more students were actively engaged for the entire period. What was surprising to me was that the first day, 99% of students were engaged. So just by introducing something new, students were already excited. For Class B, similar results with 60% or more students actively engaged throughout the 7 days, with the exception of day 3, in which 41% of students were actively engaged. For their journals, I did descriptive coding. So I read through all students' entries, and I wrote down phrases that showed up once over and over again. And the 3 main codes that I derived from this was engagement, accomplishment, and pessimistic to optimistic outlook. Some of the phrases that gave me the engagement code were, I'm very excited and ready for this project, or fun start to build this project. These phrases were similar throughout both classes. These are just some examples. Some examples for accomplishment related phrases were, I feel proud or bridge past all the tests, or I feel nice about succeeding, or my group and I feel accomplished, and there were many more. From a pessimistic to optimistic outlook, in the beginning, students felt it was a lot of work. So then we had comments like, I'm kind of nervous we don't have a plan yet, to we have a plan and I'm feeling better. So the project is slowly coming to my liking. So it was great to see that change in students. For the survey results, to the statement, I did not like the project for Class A. They had an average of 1.87, and for Class B, 2.57, showing that most of the students disagreed with that statement that did not like the project. So most students actually enjoyed doing the project, and I also utilized the Likert scale. To make sure that it wasn't just based on quantitative data, I wanted to get some qualitative data. So I gave an open-ended question and straight out asked the students, which method do you prefer more of learning? What we did before or what we did in the last 7 days? Method 1 being how we were learning before. Method 2, what we did in the last 7 days. For Class A, 27 out of 34 students preferred method 2. For Class B, 30 out of 33 students preferred method 2. So they enjoyed hands-on learning a lot more than what we were doing before. The significance. Through reflection, and implementing the intervention, I noticed that student engagement went up. Students were actually excited to be in class to the point that someone would come in at lunch and work on their project or just talk to me about their project. So I wasn't getting the same complaints anymore. And students also wrote down in their journals, a lot of them, that they enjoyed hands-on learning much more than just sitting there and taking notes. For limitations, I was limited to time since I only had a certain amount of periods, so I couldn't command cycle 2. For another one is sample size. Unfortunately, there were students that were absent throughout, and even though the work was available at home, some of them didn't complete it, so I didn't get data from all 70 students. In conclusion, through action and research, I was able to reflect, find something that was going on in my classroom that I need to improve on, conduct research, apply a research-based technique such as project-based learning, and notice a positive impact in my students' engagement. Thank you for your time. Is there any questions?
So one question.
Yeah, go ahead.
If you can go back a couple slides, right there,
Yes.
Likert, the one before. Yeah.
Yes.
Did you get an idea on Class A, the 5 that strongly agreed that did not like the project? Was it? Do you feel like it was? Did they give you any more information? Like, we didn't like this particular project, or we just don't like projects?
Excellent question. For that one, it's because they didn't like the group that they selected.
Okay,
So
so
some of
there's
them
5.
found out, they found out that it was not good to be in a group that's just your friends.
Gotcha.
Because they're going to have side conversations.
Okay. All right.
Any other questions? Turn it a little bit this way. There we go.
One of the slides, there was a 7-day bar graph there. Why do you think there was a big drop on day 3 for
For
class E?
D3, there was a lot of students that were absent that day. And when that happens, it throws groups for a loop. So a lot of groups were like thinking, we're not gonna have enough time to do the project. So instead of continuing on, they kind of like temporarily gave up. But towards the end, which I can show the data if you would like, they actually started getting to work once I started going group by group and letting them know it was okay, and that they would have enough time to finish.
Got it. Thank you.
Can you think of any instances where you can transfer this engineering design to other areas that you're teaching?
Excellent
math.
question. Yes, definitely. The engineering design process can help in all subjects because it has students basically have any kind of project. After that, they're thinking together of how they can find a solution to it. So it's a guide. It guides them through it, and it shows them even though they might not build a hands-on prototype like a bridge, but they could be creating a poster. They could be creating a presentation or a video. And if we allow them to iterate, that means they're able to see their presentation before they present it to the class, learn from those mistakes, and then give it another shot, which has that learning component.
Any feedback from your other colleagues teaching science on how their students are feeling around Amplify? And then have you been able to share with them like, hey, this is something I'm trying out?
I haven't been able to share, but after talking to at least 4 other science teachers in 7th and 8th grade, they let me know that Amplify was not something that students enjoyed as well, that it was a little bit boring, and especially 7th and 8th grade has even less hands-on activities than 6th grade. Because 6th grade only had a big one in the beginning, and then after that, it's just simulations in the computer. And then for 7th and 8th grade, they have even less.
That's really good feedback.
It really is.
Yeah.
Based on your findings, how do you plan on meshing Amplify and project-based learning?
So based on the findings, what I'm doing now is instead of having students just read and take notes, I'm changing it up, which I've also gotten ideas from talking to Anita. So in the part that I'm learning from what she does in her classroom to the parts that if they have to read, instead of just having them read as a class, I have them read in groups and they become experts in their sections, and then they create a poster and present it to the class, so they're learning from each other.
Nice.
And it's a little bit easier to digest for the
Yeah.
English learners.
Yeah.
Are there any more questions?
Me,
All
thank you.
That
Thank
was
you.
great.
That was really
Yeah.
well done.
Good job.
Yeah.
Awesome.